you a brief idea about some of the projects that we will be offering. This is a list in which, starting with the iris, so some of the quality parameters by which we can estimate the quality of a given iris image. Then this is the recognition. So as sir have said that for every project there will be one mentor assigned to you also. So right now I am giving a brief introduction about these problems, that what is the problem, what type of databases onto which you will be working, what is the input and what is the output that we usually require, and then about the pinpointed techniques and all. Means once you got interest, you can meet the allotted this student, PhD student. He will help you. The second one is the iris recognition. I will be telling you about it. Then this is the new trait, that's a finger knuckle. I will be showing you some of the images about it. So the first problem about it is that given the image, how one can extract the ROI, the region of interest that we wanted. Then again same as that the quality parameters, because you know that if we somehow can estimate the quality of a given image, it is very useful, because this quality is directly proportional to the proportion that how well it is going to be matched. If the quality is bad, it is not going to match. So one can see that this quality of a given image that we used to acquire of the same person, it is going to vary. And third one, basically we want the knuckle recognition. So third one is the recognition. Then is the force lap. So it's again a new thing. You will be seeing that what is force lap fingerprint looks like. And given a force lap, we wanted the segmented 4 fingers out of it. So that's the force lap segmentation. And then using that, we want the force lap recognition. So in the recognition also, one can see that given the 4 different fingers of a same person, we match with 4 of them, fuse the score in such a way so that we get the better results. So it's slightly different from the single fingerprint recognition. Although once given a single fingerprint, we match using a single fingerprint algorithm, but we have to fuse the result in such a way. And you know that the quality of these 4 fingers, the best quality one is the first and the second finger, and the quality is not that much good. So all these things, I mean, should have to be taken care when you are fusing the scores. And these two are basically related to the biometric template, basically the security of our biometric trait. So template security and the biometric crypto systems. So Kamlesh will be telling about them. And this is the indexing. So given when you are working on a huge amount of database and you want it to match, so suppose that you have X images, so how many matching you have? You will be having X square matching exhaustively if you wanted to find out a match. But somehow, so it's a very big number, X, it's a square, so it's a very big number. So indexing help us to do, we do some sort of pre-processing, we save them, and then when you wanted to match a single image, we need not to match with the whole database. There will be some small amount of images onto which we simply match that, and we finally got the result. So indexing will help to do this thing. So starting with so there is a general 30% weightage is given. At max 2 students mentor will be allowed, and finally we'll have to submit a project report along with the GUI based the recognition and the verification system wherever it is required. Sometimes you will be requiring you will be calculating the quality, so you will be given an image, you will be printing what are the quality attributes and the final quality score, and you will have to give a demo also. Starting with the quality parameters, so as I've said that the higher the quality and the matching performance increases with that, and you can see that for the given iris image, the quality degrades due to the error when you are capturing the data. So at that time, because of some errors, because of the compression, you can know you see that because of the compression there will be some error. Damaged equipments, it is especially, I mean, suppose that you are working on a camera and there is some mark or something, some dust which is on the lens, and because of which you are getting some bad quality images. Illumination, it's a most important thing, the poor illumination. Sometimes you see that the light is not properly falling on the eye, because of which you are not getting the good quality of images. But usually one can see that given a iris image, so these are the different iris images. Here you can see there's a normal iris, but this is an occluded iris. Now here one can say that if you see that you directly use the parameters of any algorithm by which you can say that the quality of this image as a whole, the quality of an image and the quality of an iris image, both of these things are different. Maybe you can say that it's having a good sharp edges, so you can say that the image is very good. But here if you can see that the edges are very sharp, you are getting most of the things, brightness is fine, illumination is fine, but there it is occluded. Now this is something which is exactly related to the iris itself. If it is not an iris, if it is a face image, you won't be that much bothered about. You say that okay, you are getting the full face, you are getting the nice edges, properly illuminated, but here because it's occluded, so this is something, this is a parameter which is going to affect the quality of the iris. So this is the thing. So out of all of those parameters which we used to see when we used to say that okay, this image is better than that image, one can say that this image is better than this image. Why you are saying this? Because now you have seen that it's occluded. So this is the thing that we actually want. How can we quantize that how much it is occluded? Similarly, this is a defocused image. You can see that the image is not properly focused. Here you can say that because in the case of iris also what happened that our eye move very fast. So when you are capturing this image, what happened that because of some motion blur, you are getting this sort of image, improper illumination. And here it's a dilated iris. So you know that when you are capturing an iris and you are placing some light source in front of it, what happened that eye used to dilate a bit because of that light. And what is happening, you can see that here the iris portion is bigger, here the iris portion is not that much bigger. Here you can say that this is a perfect ideal iris image that we want. So these are all some of the abnormalities that we used to see in the iris image. So the thing is that we wanted to find out automatically, of course, that given this sort of image, I wanted to know that what is the amount of occlusion that is there in this image, what is the amount of defocus, what is the amount of illumination, what is the amount of motion blur, or that how much it is dilated. If we calculate these things, then we can say that these are the attributes which are related to this particular iris. And yes, of course, what is required then is that we have to identify these different attributes, then quantify these quality attributes. You just have to find out what is the value, and then using those values you have to find out the complete normalized iris score. You have to fuse all of these parameters in such a way so that you are going to get a normalized iris score which is based on these attributes.
See, go back to the image. See, what happens that you are expecting that first ROI is there.
Yeah.
And from that iris area,
Yeah.
first is that whether the iris area or correctly.
Yes, yes. That can also be a parameter. So, yeah, yes.
And then amount of occlusion.
Yes.
Amount of noise, like how.
Yes, yes. Yes, yes, yes.
Right?
So I will. Yeah.
This amount you want to add there.
Yes.
To get value of 1.
Yes.
Am I right?
Yes, yes. So I will be showing you that. Okay. So given we used to get images like this, but what we have to find, we have, so there is a proper different phase in which we do the segmentation. We find out this circle and this circle. It's basically a donut. Yeah, that we will be providing. We will be basically providing you this image, and also I will be showing you the segmented and the normalized images. So you will be getting all of these images. You need not to do the segmentation, you need not to do the normalization. All of them will be given. You simply have to find out that given this image and this set of images, what is the value that we want, which is by which we can assess the quality of the image. Now going on to the recognition. So as I have told that once you know the quality, so recognition, the best algorithm, I mean the iris is the best trait. It used to give us the best results as far as the accuracy is being concerned, and because it have a huge amount of random texture within it. So several things one can see here which is not properly visible. Some eyelashes, eyelid. This is basically the donut portion that I have shown you. The donut portion, the black region and the outer white region. In between this, the portion that is actually called as the iris. We wanted to segment that thing out of it, and then once you got that donut portion out, then we normalize it in a strip. It's a rectangular strip, and then we will be working on that strip. So basically, those who will be working on the recognition directly provided the cropped normalized iris images, and you will be working on this itself. These are some of the images I have shown some. So these are the 3 databases onto which we will be working on. This is the CASIA interval, CASIA LAMP, and this is the ITK database. This is our own database. This is the size of the databases. So interval it basically consists of 249 subjects. LAMPs having 411 subjects, and ITK is having more than 1000 subjects. Session means that the images that are acquired, they are acquired in 2 sessions. In the first session they have acquired 3 images, and in the next session they have acquired 4 images. The characteristics like that, it is having the KCI interval images are very good images, having a very clear texture. It is lamp, so it means that these images are taken with lighting up a lamp and without lighting up a lamp. That's why it's having a variation in the illumination. So they wanted to see that how much variation it is there because of the illumination. So first it is having 20 images, first 10 images are with lamp and next 10 images are without lamp. But it is in the single session. I mean, session means that first you take first set of images, then you wait for say some 10 days, 15 days, sometimes 3 months, 4 months, and after that you are taking the images. Here they have taken it in a one go. 20 images, first 10 images are illuminated, next 10 images are not illuminated. And here in our case, ITK database, it's a huge amount of images that we have. It also taken in 2 sessions and 5 in one session and next 5 in the second session, and the quality of the images is fine. It's having good quality images.
So does it mean that I take the IIT for IIT image as the base image?
Yes. Yes.
And with respect, because I want to tell my image is very good.
Yes.
So what does it mean with respect to what?
Yes. So that's what sir used to say. Wanted to say is that suppose you're trying to find out some of the quality parameters. So once you got these algorithms by which you are estimating the occlusion, you are estimating the motion blur, you are estimating several different parameters. So what do you do that? Given these good quality images, you find out these parameters, and then you can use different classifiers, because now you have a huge amount of images which are good. So what are the parameters by the virtue of which they are characterized as a good images? Those parameters you have. Now using those parameters you can give it to SVM and different other classifiers by which you can find out, you can construct your own this classifier by which you are saying that it's having quality 1, 2, 3, 4 and 5, good or bad, depending upon the, so you can use these images as the good quality images. And this is the overall structure. So this is the acquisition, this is the segmentation, and this is the normalization. So as I have told you that for recognition, for anyone, I mean you doesn't have to do this thing all. This is in itself is a very complicated problem. Given this image, you wanted to find out this circle. Now you can see that red. This is the donut that we actually want. Once you got this donut, from here you have to find out this normalized image. Now this is basically in Cartesian coordinate. From here, if you convert it into the polar coordinate, then you will be getting a rectangular strip. That is the thing. Up to this you will be getting. Even if you want, then you can get also this enhancement. So from here you will have to different feature extractions and different. So once you got the enhanced image from which you can get the feature extraction, these features are extracted and they are matched with the features that we have in our database, and the one with which it's matching most, it's said that this person is that person. In this way we used to decide the particular matching.
The previous slide,
Yeah.
the thing that we have to predict the class in
Yeah.
HP,
Yes.
whether it is ocular or not. So is there a database from which we have to validate? As in, are these 1021 images
Yeah.
classified already?
No, they are not. So first of all, these are subjects, images are 20,000. So images are not classified, you will have to classify.
So how do we validate that our classification is correct or not?
So see, on the test, so given say 20,000 images, you somehow take some 500 images which are occluded, and then out of that you work on say 250 and other 250 for the testing. In this way we used to work. Ultimate goal of this quality thing is that once you feel and you see that your algorithm is working well, and you are saying that the quality of this image is good. Now how you justify? We need not to justify that whether it's properly occluded or not. The thing is that it should be matched properly, and how it is matched, it should be matched using the recognition algorithm. So if you are saying that the quality of this image is good, first thing is that visually you can also justify that thing, that why it is good, because it is having less occlusion, it is having less motion blur, it is having this thing and that thing, it's having good amount of illumination, sharp edges, several things. If you can justify it, then it means that okay, your thing is working well. Second thing is that how automatically or some graph which can show you, so it means that if you are working on good quality images, you will be having better accuracy. So the ROC graphs will be lower towards the axis.
Is it your question? Your question is?
My question is, out of the 20,000 images,
This is what I can tell you, out of 20,000 images, most of them are book quality. That is under control environment, and we have collected the data students are very they were comfortable to give us. So their eyes are open. Fine.
I wanted to know that whether
They are not
each of the
classified.
20,000 images are written like popular.
No, it is not there. So that's what I'm saying.
See, so for example, if you have to think about the operation, you divide these ideas, one way can be to divide these ideas into frequencies services. And you see, when they are putting all the 9 blocks, right? This is the people area, so you put design in this area. So some places you may find that it's fully open, but nothing is there, all fine, all same grade. That is okay. Right? So that way you have to think little. And in the case of occlusion, here occlusion and other things, there also you find similar type of idea. There are too many black lines are there.
So it's just like that. Suppose given this normalized thing, as sir is saying, that you can divide into different blocks, and then you know that because if it is occluded, it will be having more black thing or something which is not the iris. So you can threshold it in such a way so that the part which is occluded, it will be 1 and the other one is 0, and then you find out how many are 1, and in this way you can say that it is 80% occluded or something 50%, 70% occluded and things like that. So in this way you can quantify, and there are some, so once you start working on it, I can tell you several methods by which the things are being done. Some codes are also there. So this is for the iris. Yeah, so for the recognition, these are the 3 parameters that we use to think of. That is the equal error rate, where the FAR is equal to the FRR, the discriminative index, and this is the ROC curve, basically the curve between the FAR and the FRR. These are the 3 things that we will be seeing. Now starting with this knuckle based authentication system. So in this also we will be having 3 things: extraction and the quality parameters and the recognition. So these are actually the images. So the Poly University, it's a Hong Kong university, there they have developed, acquired these images. So this is basically the outer part of the finger. They have a device by which they have captured. These are the images, JPG or JPG or BMP format, and these are the images from the same subject. These are the full images. Now the first thing is that the ROI extraction, and this is very straightforward. This is the thing that we want. Given this, it's a whole image. Now what we want is that only this much part from all of the images in synchronous way. I mean the part that you are going to collect from this image, I mean every time you will be getting the same part out of it. Now here you can see that this and this are the corresponding ROIs that we have extracted from these images. This is the first problem that we wanted to work. There is some, it's not a very difficult thing given the algorithm. Very simple algorithm, you find out some edges over it, and then you can see that here the things are some edges which will be convex and concave edges, and then you find out this middle line because it's not having that much concavity, and then using that you can divide it into 2 parts and then fix up an ROI. That's not a big thing. So this is one problem, that out of this we wanted automatically this thing, and every time the same area, I mean if your algorithm is working, from this you are getting this and from this you are getting this. It shouldn't be like this, from this you are getting this and from this you are getting some other portion. So this is the first problem. Sir, from here, sir, it depends, because here these images are heavily illuminated in between the center. If I show you some of the images that we have here, this is the first one. Now here if you see, because it is having some illumination problem, but it's not having that illumination problem. So here you can see that it is having some texture over here also. So because here the camera, the flash, whatever they have, because of which it is heavily illuminated here. So some of the features are lost over here. So this is the second person's image, and some third person and the fourth person. So these are 4 different images of different subjects. Now if you see that the quality of the image is changing in each of the image. Now one can see that it's having illumination, it may not be having illumination, but one can clearly see that it is having good amount of texture within it, and everyone can say yeah, yes, this is better than this, or it is better than this, or vice versa, whatever. So how you are seeing this thing? And again the same thing is that you have looked upon the edges, you have looked upon the brightness, you have looked upon the sharpness of the image. So this is the thing that we again want, that the finger knuckle quality parameters. What is the edges? Out of the edges we see that how much they are connected, and because of that you can say that okay, this is a good edge, it is having a better edge structure than this one. And also, as you know, that if there is something which is having some pattern, it shouldn't be, in knuckles it is having some amount of connectivity within it. It shouldn't be something like that. Suppose that you have here something, then here something, then here. It should be going very haphazard. It should not be very haphazard. So if you find out some connected component, and as that is also being done over these things. So those who will be working on this maybe thinking about the edges and the quality of edges that you have, the sharpness of the image, the illumination, because as you can say that it will be poorly illuminated. One can say it's having huge amount of illumination, because of which one can say that the quality of the image is not good. And here you can say that it's properly illuminated. Then some of the images are having some blurriness in it because of the motion or because of the sensor. So these are some of the hints that I have written. Some more things you can think of and you can add in it. These are very simple. In MATLAB, if you find out these things, not more than 4 or 5 lines, you can calculate these values, quantize it, and then you will be having the quality for this thing. Finally, again you should be returning the normalized quality score for any given image, and it also follow the visual inspection. As I've said, that if you are seeing that the quality of this image is better than the other one, you should have to justify that why it is better. By looking also you can say this thing. Next one is the finger knuckle recognition. So the database, the same database I have told you, it is having something like 165 subjects. Out of from these subjects 4 fingers are collected, so something like 660 fingers that they have collected. And they have collected data in 2 sessions, 6 plus 6, so something around 8,000 images are there in this database. And the testing strategy again remains to be the same, that the first session images are matched with the second session images, and the performance parameters again remains to be the same. So if you are calculating, drawing the ROC curve, that I can provide you that how you can draw the ROC curve, and that is a simple script that you can be using. So given your score file that you are generating, this is the ROC curve that you will be showing us later. And the better ROC curve means that suppose that if this is FAR and this is FRR, so the curve which is, if there are 2 curves, so one can say that this curve is better, and one curve represents a single system. So if you are having 2 systems, then you will be having 2 ROC curves, and the curve which is lower, that system is better than the other system.
In that case, what are you going to give that?
I'll be going to.
Is the extraction module also?
No.
Or are you going to only the ROI?
ROI, yes. Only the ROI, and then they will come. I'll understand. I'll just see that what they are thinking, and then tell you that what are the different approaches out of which you can select whatever you want to code. Because you are working on MATLAB, input is ROI, and you will be returning. Input will be 2 ROIs, and you will be returning. So for recognition, and you will be returning a single score. And the 4 slab. So yes. So there is a 4 slabs fingerprint based system. So in which everyone knows that it is a fingerprint. It's having ridges and valleys, and because of which you will be having several minutia points within it. So there is several minutia points that you can get. There will be several missing minutiae because of the improper minutia extraction algorithm. Then you will be having some spurious minutiae also. But first let us see that what is the 4 slab this fingerprint image is. So this is the device that we have. Using this, if you can capture a fingerprint, this is like this, and these are the 4 different images of the same person taken once. And it's the index, middle ring, and the little finger. They are acquired, and one can see straightforward that once you have to put the pressure, so you have to give a lot of pressure while giving your data, and one can see that if you just try to give more pressure, you will not be able to give much pressure on the little finger. So straightforward you can see that the quality of the little finger will be very bad, and the recognition or the accuracy using only the little finger will be also very bad because of the quality. Yeah, so this is the first problem. So given this, up to this is the image that we will be giving you, the 4 images within given image, and out of this you will have to extract these 4 images, 3 and 4. Again, as you see that the background is white and these are black. So this is a 0-1 image, you can see, and very easily you can find out these blocks. The important thing is that where to crop, because you have to crop at this knuckle line, the first knuckle line. So that is also a thing that we want, that given this, first you divide it into the region of interest that we want, and then where you want it to segment it. That's the knuckle line. You calculate that knuckle line efficiently and then crop from there. So every time you will be getting, whenever you are getting a fingerprint, you will be cropping it from here, not from here. This is because of the algorithm's inaccuracy. Once you got the knuckle line, it will be cropping from here, and every time you will be getting the same exact size of the ROI, it will be matching properly. So the segmentation, there are several steps. So first the pre-processing orientation. So you find out the orientation, because sometimes what happens that given the fingerprint you are giving in this way, sometimes you are giving in some different orientation. So first of all you have to compute the orientation, then make it a vertical, and then you divide it. Also you have to identify the hand, because most of the time what happens that we use a particular protocol that first you will be giving the right hand data and then you will be giving the left hand data. But what happened that sometimes it fails. I mean, persons are coming giving the data, and because huge amount of persons they are giving the data, someone is given right and someone is given left, change the order. So what will happen that the data that you are expecting of right hand, it is of the left hand. So if we have a hand estimation algorithm, that is also, and it's a very simple thing. Hand estimation, one can see that this finger is the bigger finger here, this to the left of it it's having 2, to the right of it it's having 2, so something like this. So it is also being done. And then finger mapping. So once you have got the 4 blocks, you will have to map it with the proper, that if it's a little finger, it's a middle finger or whatever. So it depends upon the hand. If it is right hand, then the blobs that you have got, it will be mapped in a different way. If it is right hand, the blobs will be mapped in a different way. So we have collected a huge amount of data for using this force level scanner. The rural database that we have gone to village, and we have collected huge amount of data, something like 6,000 images out of say about 1,000 subjects, and it's a very typical data. You won't get this data from anywhere. The thing is that we have gone to village. There the persons who are working in the farms, who are working doing some sort of labor things. So what happened that the quality of the print that they have, most of the time it is very fade. Our high quality fingerprint scanners, they are failing over there to acquire their data, because the print is so worn off, it's teared. I mean, most of them are not having even the fingerprint, you know. Some of them are of 60 or even more than that age, and just they have came to give the data, and what we have seen that it's simply, I mean, that the state of the art machine is not able to capture that data. Somehow we have captured, and this 6,000, so this is a very hard, I mean, you can say very difficult database. It's a very difficult database. On the other hand, we have also our ITK student database, or something like 1,000 students, 6,000 images, and this is a good quality, because here all of our fingerprints are very good. So if you're working, so you will be working on both of these, depending upon the accuracy. You can see that how bad this data. Once you see this data, you can say that, oh yeah, it's very poor than the ITK database, and the amount of, or the accuracies that the state of the art system used to claim, it is very high. I mean, it's something like they will fail in say 10,000 or 1 lakh. In 1 lakh matching, they will fail in 1 or 2 times. But if you use that algorithm, the state of the art machine algorithms and the scanners use this data, then you will see that it's failing quite regularly. It's very difficult. So these are the 2 databases that you will be working on. Again, the first session. So as I have told you, the images are collected in 2 sessions, 3 plus 3. So first 3 images are from the first session, and rest of them are for the second session. So first session images will be used as the training, and the rest of the images are used as the testing set. And again, these 3 things we used to calculate. And now about the security, he will be telling about the.
I will be telling you something about the biometric security and the related issues, and actually I am talking about the security of the security system itself. All of you know that we use biometric systems to secure some area, that if the person is authenticated well, then he can enter the system. But now we are talking about what happens if somebody captures that system? What can be the method so that we can save the system for not being captured by anybody? So there are actually two areas in the biometric security. The first area actually deals exactly what I was telling, that how the system should be protected, what are the techniques to protect the system so that nobody can make fool of it and may replace the things and kind of thing. I would explain more on this very soon. And the second thing is a biometric crypto system. Actually, all of know the cryptography says that if I want to send some message from one place to another on a public system, so I have to encrypt that. The encryption actually requires some key exchange kind of thing. I have a key, you have a key, and we exchange that. But in the biometric system, we know that whenever we give our data and the second time, that doesn't match is actually. So if I use my exact biometric information as a key, so it is not going to work. But there we are trying to develop some systems which actually are resilient to small changes that actually are actually the properties of the biometric systems. So these are the actually two aspects on which I want to focus, and I want to give some light on that. The biometric template security actually says, you know about the templates actually. What is a template? Actually, when we, for example, if somebody gives the fingerprint and at the during the registration, and after some time he again comes and gives the second impression and he want to get authenticated. So we actually don't match the fingerprint as such. What we do, we extract the minutia find from the first impression, and we also extract the minutia from the second impression, and those two minutia points are actually matched. And there can be another methods. For example, we cut out some circular regions, and using those features we are going to do the matchings. So the matching is actually not done actually on the exact images, it is done on the template. So that thing, that minutia is called a template, the set of minutia is called the template. So we want to secure the template. Why we want to secure? So that just seeing the template, person should not be able to understand whose template it is. If in a system, what I would do, I would place all the things into some directory or in some database structure. I am at the registration time, I would take the fingerprint images of everybody, put it into the directory or put it into some database. Then at later point of time, somebody want to attack, what he would do? He would just see the ID and he can replace the things. So how can I make the system anonymous with the IDs? The first point is, how can one question is this. So you can try thinking about that. The second thing can be, if anonymity has been done, think about that. The system which have which is free from the ID names, then how a person can see the things and should not detect that whose biometric template it is. For example, I have many biometric templates. Just by seeing the biometric template, person should not able to know whose biometric template it is, because if he knows, so he can replace that biometric template with his own, and then he can do the attacks kind of things. So some of the techniques, like for example, if I have a biometric fingerprint, so what I can do, I can exchange the thing. I can do some permutation over there. I put this information over here, and I do some kind of permutation of these things, and using those permutation, I create a new kind of things, new kind of map. I create a kind of mapping over there, and that is a permutation. And if I put this permutation into the database, so just seeing that database, nobody would be able to figure out whose actually this impression is. And when the second time person comes, I can use the same algorithm and go and in the encryption domain, I can do the things well. So there are some open issues over here itself. So we can think about developing the algorithm for that and doing some testing over that, so that we can develop a better systems. In the biometric crypto system, the initial efforts started from the 2000 itself, where the people what they did, they tried to come up with some canonical biometrics structures. What does it means? Actually, if I have an iris, I give my iris image once, and if I second time I give my iris image, so it was estimated that maximum 25% is the maximum. Generally 5% bits are different. From the first image to second image, 5% images are 5% bits are different, and at a maximum 25% can go wrong with the second impression. So what I do, I can take 25 continuous photograph after some little duration from a person's iris, and then using some voting schemes on a particular bit. On a particular bit, I apply a voting scheme. What is the bit which comes most number of times? Then using that information, I can come up with some canonical structure that this is the particular structure that should remain. If I take the 26th time, it is very near to that. Then what I can do, I can create some error correcting code for that. That is, the given these 25 images, if this is the canonical structure, what should be the error correcting code which makes them very near. Any image coming, any new image coming, I can apply that error correcting code to that becomes very near to this canonical structure. So these kind of actually techniques came up into the picture, and another technique is biometric based fuzzy system, which actually tries to develop some functions which are doing hashings over a local domain, local place domain, so that they come up with some structure. So these are some cryptographical issues over there. If you are interested, you can try to come into this area, and I can guide you on that. Next is the indexing. Uma madam would tell you.
So in general, you have studied all basic things. Performance of any biometric system is measured based on the accuracy, and then how much error rate you have. So error in terms of false acceptance rate, false rejection rate. So mainly any biometric system, how much error it is having, how much accuracy it is having. That is the two main performance. Based on that, you can say whether the system is performing good or bad. Now the problem in indexing is different. It is dealing with the scalability. Given some 1 million records, actually we do not have, or in terms of thousands, let's say 7,000 images, 8,000 images, you want to, how quickly you want to get the results without compromising the accuracy. That is the problem in indexing. Actually, I don't want to give the full problem of indexing because it takes a lots of time. I want some specific subset problem on phase indexing. I have done a part of phase indexing where initial part is missed, that you can do. So the specific problem is this: when you do the matching two images, if you do the registration, otherwise known as alignment, if you know the words, it will be alignment or registration. And given at the time of at the time of enrollment, if the images are straight, and at the time of recognition, if it is little bit translated or rotated, then it is very hard to match the two image features. So what generally they do, they'll do the alignment process, alignment or registration with the availability feature. If you do not have the feature, then you cannot do the registration. What I observed is in fingerprint, there exists a point called the core point. That core point, if you see, it has, sometimes the structure remains like this. This is known as left loop because the reach flows towards the left. And these are the very popularly used structure. This is called the right loop. Otherwise, some arc pattern. And there exists another arc pattern which normally doesn't occur. So the specific problem that is given to you, how to determine the, this is a part of the ridge. We consider some other ridge flow. You have to detect what is the core point. You have to detect whether it is a left loop or right loop. Actually, when you do the matching, before matching you just align based on this 4 point, then feature matching is not much difficult. This is one problem known as automatic, sorry, I'll write automatic 4 point. Otherwise you can think it as alignment. This is a subset. Alignment you can do through 4 point, or alignment you can do with the rich flow itself. Actually, if you do the alignment with the rich flow, it is a bit difficult problem, but you can think that alignment, given an image straight and given another image which is a little bit translated or rotated, how you can move that fingerprint straight such that it will coincide with the image. This is known as alignment problem. So this will help to direct the matching easily. You want to write something?
Yes, we have the 4 point detection algorithm.
Yes.
And that algorithm has the accuracy of 90% of
80%.
80%. So that algorithm, if you want, we can give it to you.
Yes.
And then you based on that you can learn yourself, and then you modify.
You can improve. We have automatically detected 4 point, but it is performing on public database 80% results has come, and you can understand the code and you can improve. That will help you. This alignment problem is available in the literature, but we haven't tried. If you want to give a try, you can do that also. Both are related for registration alignment before Venetia matching. Another one is in the face database. Face database indexing also I have done. Now, as I said, the registration. Now, here the 4 point is available, so we are doing based on the 4 point. Now, in face, I thought nose tip is available. So, let us think registration based on the nose tip. And I have marked manually the nose tip and I have achieved some 90% result. Now, I want to find the automatic nose tip detection. That is a straight problem. So, given a face, how to detect the nose tip automatically. So, this is simple geometric operations only. So, you can find the 2 eyeballs. That eyeball detection is existing in the literature, and you can estimate the distance between the 2 eyeballs. Then draw a straight line that will pass us through the nose, and you can find some distances from nose tips. You have to study further so that you can detect that nose tip easily. So this is a subset of that face indexing. And if you want to interest, you can want to indexing as well. That is also available. I'll write in this automatic nose point or nose tip detection. Followed by indexing. If you have an idea of indexing the whole image face databases, you can explore these things. To specific problem.
Read out of any of this problem. Then how?
What is 4 point able?
Fingerprint. You check out your finger. This finger. And you see that this type of line is there. Is there? And this is your code.
The slides.
Okay. Now, see, this ridge line detection algorithm exists.
Yeah.
All those algorithms exist. Only thing is that using these algorithms, you have to estimate this is the probability here. This is the point.
See, the rich flow comes with this edge towards left. This is left. Ultimately, the peak point or the local highest peak point is known as the pole point. And here it is, this is also left loop. That is known as right loop. And here it is pole. No arc is available. 90% of the fingerprint having left person only has other that we can
Or
detect
no
manually.
code.
No
Or
code.
no.
No code.
It is not guaranteed that you will have that. But see, if I have the 4 point, if I can detect the 4 point automatically, then we can solve several problems. Several problems means that, see, this is the registration point, as you was telling, right? That you have to register, align, based on, otherwise somebody's finger may be up and somebody's finger is down, and mapping itself is a problem. But if I have the registration point, I register it, then I find out the coordinate correspondingly and match that. Distance I can easily obtain. So manually 4 point we have detected manually and we have seen the results. And automatically also we have down, we have obtained, but the result what we are finding it is not 100% accurate. So this is one very challenging problem. You can do it, it's very useful. And if you can show on our database, whatever database I have, if you add manually we have obtained the 4 point, and if you can obtain it is within certain delta value, and if you can show that one, I assure you that you will be getting very good mark. Right? That is the thing. These are challenging problem and very good problem, interesting problem. It is not that it is not solvable. It is solvable. Only thing little concentration is it. Then this problem, phase database, nose point, geometrically you have to define. This eye center point is known to you. It is given. That is, you know, if you take the inverse of your eyeball, then it will become the white point. Straight away. So you know the center. These two centers is known, and if you draw a line and if you divide it, then it will be like crossing through this one. This is a very geometric you can define. Now you know this point and then this point also you can find. If you again divide it, then it is the center ellipse you will be getting. And also there is an anthropometric tells the distance between the center points and the nose tip is also known to you. This is defined. If it is not defined from this point, if you draw a line from this point also, there is a triangle, you will get that triangle. From that also you can determine what is the nose tip. These are only simple anthropometric technique you have to use to apply. If I know this point, again, same as we have, I am telling on the fingerprint things, that we can easily register the two images, and if I can register the two images, I can have the good indexing technique. So we are not going to give you the big problem, we are giving you only the small problem. That complex problem, what complex is telling, there is you have to do little theoretical study. Am I right? And we also don't know how to do it, but it will be an important parameter. See, one way is that I collect the image, and then image has to be transmitted. How safe is my image? Right? I have taken your fingerprints. Now I am a franchisee. My job is to collect. I don't have to do anything. I have to transfer to the head office. Now the image, if I transfer, then instead of your image, I can put my image and I can transfer. Right? In between, some intruder will be there, and he changes your things and he sends my image or your image instead of my image. So that will be chaos. So some security has to measure you. This is one thing. Then you have obtained the features from the fingerprints. How safe is my fingerprint features? Right? That is also another thing. So there one method is known as the cancelable biometrics. I think how we will serve it. That also one can think. That is it the only way, or there exists some other way? Right? Then Aditya has given quite a good number of problems. One big problem here, whatever he has told, that fingerprint matching, then you need to get the minutia points. Now, I feel that he will be giving you the minutia point finding algorithm, right? So, if you feel that no sir, I want to design my minutia point algorithms, you can design. Then that itself is a problem. But with the understanding that you will not be giving us the algorithm available in the web. So that is the right, that is cheating. Basically, that is cheating. That we don't expect from you. That is the first year, second year students that do. So what we want that Manisha, if you feel that, sir, I want to obtain the Manisha point detection algorithm, fine for us. If you want, no, sir, Manisha point algorithm, I am not interested, then he will give you the Manisha point algorithm. But you give us the quality parameters, what are the other issues you told, matching, right? Then, you know, this, as you know that these 4 fingerprints are not equally good. Some of them are giving very good quality, some of them, because the amount of pressure you have given based on that. So this gives a very poor quality image, but whereas this gives you the very good image. How do you know that? Whether this is giving you the good result or not, that is not known. So you have to test it and then you have to put weightage on each finger. That weightage is required and then you fuse the results to obtain one matching score. So this is the thing. Those, while we will be covering all those things in while you are regular class, that will be easy for you to understand. But in the meantime, you have to start your thinking that which project you are interested and by what date you want. Before by next week, is it okay? This will be kept on your. Can you keep it on website? You will keep all these slides. You read it, try to understand, and you know who is what. They are sitting in 109 and 106, right? So you can read them, discuss. Only thing that don't come one after another. You fix a time again and take one slot, right? Like that. Initially. After that, once you select, anyway, because it is their interest, they also will spend their time. Any doubt? No doubt. It cannot be. Either there should be full of a lot of doubts, otherwise you have not understood.